All right, so to get that information, you just got to label your drawing here. So your minimum is the lowest point on the wheel. So we know our minimum's 7. Then your midline, and then your max. All right, so the radius is, my radius is 22, so that means this is 22. So my midline is going to be 7 plus 22, 29. And then 29 plus 22 more feet is going to be 51 feet. Okay, so now I know my max and my min. So once you have that, now you're just going to plug those in and do the math. Okay, so for me, take away 7, 51 plus 7. That's 58. 58 divided by 2 is 29. How'd I get it? Okay, so the problem gives you so the distance to the bottom of the wheel, that's your minimum. So I know that's 7. Okay, then the next distance is the middle. Yeah, because I know the rate, if this is 22, so is this. So the midline would be 7 plus 22. So that's where I got the 29. And then the top guy is going to be your 29 feet, and you add 22 more. 29 plus 22, and that puts me at 51. Okay, 44 divided by 2, 22. All right, so I got A and I got K. Okay, now all I need is the frequency, which in this problem is the W. Okay, so you'll be able to use your notes, and on your notes you have the formulas. And so we have a formula for B that we used yesterday. So you had this little formula sheet here. Yeah. Okay, can you email me that? Do it again. I'm sorry. All righty. Okay, so I'm going to take this information right here. These are your formulas that you want to be using. Paste that right here. All right, so to get the frequency, we're going to go B equals, and the instructions say use pi, so we're going to use 2 pi over the period. So your period in this is going to be different than mine. Mine is every 50 seconds. So my period is going to be 2 pi, or it's 2 pi divided by 50. That's going to be my frequency, which is just pi over 25. Now, when you go to type this stuff in, it says leave it in pi. Don't change that to a decimal. So this going in would look like 22 sine pi over 25 t plus 29. Yeah, question? Anybody need help with theirs? Does anybody need help with this one? I'm going to be asking you questions that we've been doing off of the Math Excels. In this particular one, yes. In this one, you're not putting it in as an equation, you're just putting in the parts. All right, so mine was A's 22. A was 29. And W was pi over 25. Oops. 25. All right, so you'll definitely see one like that. If the frequency is equal to the period divided by 2 pi divided by the period. So what you're doing, you're just using this right here. What's your question? Okay, what's the problem tell you? How many times does it take to go around? Every 50? Yeah, so that's P. So to get the frequency is equal to 2 pi divided by whatever your period is. So in this case, that's 50. That reduces to pi over 25. And there's no phase shift to worry about on this. So you don't have to worry about sliding it or anything. Okay, now the next one, you're answering these animations. All right, so we want to find the period on this, so click that. Okay, you want to click sign, show the guidelines, show the labels. Okay, and then hit time and let it run. So this is the sine function that's measuring your height above the ground as this thing rotates through 6 minutes. All right, so that's what that does. Now, if you go down here, guys, if you look at this tool where it says height, if everyone would look up front, height, this line, when you drag this line, you can put it at any height you want. So like that's at 88 feet. So later on, when you got to answer the height questions, that's what you're going to be doing, moving that along. Okay, this is just moving the time along. So if I wanted to know, how high is it at 300 seconds? So I want to get that at, like, let's say 300. Okay, now look up here. I set that at 300 seconds. If I want the height, I just mouse over the very end of the graph. So at 300 seconds, I'm at 37 feet. And if I said, what's my height at 120 seconds? Well, I'm just going to move this back to 120. Oop, too far. If you use the arrow keys, a little easier. Now, if I mouse over the end, 37.71 is my height at 120 seconds. Okay, so that's how you're going to be able to use these tools here in order to answer these questions. All right, so the first thing is, what's the period? Okay. So what is our period there? 140, yeah. Any questions on how to get that? Say that again? Go over it? Okay. To find the period is from corresponding points. So 2 high points, 2 low points. Let's see here, find my pictures. Nope. Nope. Sorry, I'm trying to find where I pasted pictures. Should be over here somewhere. Right, it's the same thing. Okay, so when you do this, you take your period, which in our case was 140. All right, and we divide that by 4, and that is equal to 35. So 35 is where you should be at, that's where the max should be. But it's not. The max, this max right here, it's at 70. It's 70 seconds in. Okay, our max was at 35 seconds in, which is like here. Okay, so what we're trying to do is to take a sine function. 1, 2, 3, 4. Our sine function looks like this. 1, 2, 3, 4. And we want to take that and slide it over to there. So our high point is at 35 seconds, right here. That's 35 seconds, and we want to slide it 35 seconds to the right so that they match up. The way you got that was 70 minus 35, 35 seconds. Now, your 140 divided by 4 is 35 seconds. It shouldn't mark it wrong. I don't know why it would do that. That's annoying. I'm going to put in 35 seconds. Yeah. So 35 and 140 over 4 is the same thing. All right, now the cosine function part. All right, if you look at this graph right here, and you click on cosine, okay, go to formulas. That's the sine formula right there. Now click on the cosine formula. You see how there's a negative in front of the cosine? So that negative meant it's a cosine graph that's been flipped. Okay, so for example, okay, normal cosine looks like this. Remember, cosine starts here and goes this way. So to get that graph to match the graph that we have, we've got to flip it. I don't know if I can't turn these. I got to take that and flip it over. Rotate. And now it matches that. So the answer to that one is you have to vertically reflect a cosine so that it matches the model. So choice was A. All right, the next question's asking you, so this is B. Okay, use the height slider to set a line at 100. The question is, when the rider is at 100 feet for the 4th time, is he going up or is he going down? All right, so if you look at this, get rid of that. Okay, I'm going to set the height at 100. So I'm going to move this bottom slider to 100. All right, when I mouse over these points, this is the first time I reach 100, 46 seconds, then 93 seconds, then 186 seconds, and then the 4th time reaching 100 feet, I'm at 233.1 seconds, and I'm heading downward. So my answer here is going to be I'm heading downward. Okay, and the time when I moused over that was 233.1. Okay, all right, almost there, almost done. All right. At exactly 320 seconds, the Ferris wheel stops. Calculate the height of the rider when T is 320. So we go to our animation, and now I'm going to use the time slider, and I'm just going to reel it back till I get to 320. The time is right under the Ferris wheel. And if you use your arrow keys, it's a little easier. So that's my, right here, I'm going to go to the very end. That's my height. At 327, at 320, I'm at 84.24 feet. That's my height. 84.24. 84.24. Okay. Now this last one, you have to type this one in a kind of a funky way. All right. So we want to write our equation here. So take this. All right, so we're trying to find the equation for this ocean wave. Okay, so you get your high and your low. So you're going to use your numbers, but A is equal to the max minus the min cut in half. So for me, my crest is 2, the trough is 0, right? And then I'm going to divide that by 2. So A is 1 for me. Okay, D, the midline is going to be 1. It's going to be 2 minus, or 2 plus 0 divided by 2, which is also 1. So there's my midline right there. Okay, all right. So when I go to write out my formula, I know it's going to go 1 times sine B x minus C plus 1. So you really don't need that 1 out front. Okay, now we got to get the frequency. So our frequency is B equals 2 pi divided by whatever the period is. So you look at your drawing, I'm going to go high point to high point, 45 seconds, 9 seconds. 45, take away 9, and that is 36 seconds. That's my period. So you do it for whatever your numbers are. And then it's 2 pi divided by whatever you get. So mine is going to be pi over 18. Yeah, 18 goes, yeah, it's going to be x. Now I got to see if there's a phase shift. All right, so let's see, the whole period was 36 seconds. If I divide that by 4, I get 9. So the max should occur at 9 seconds. Now, when I look at my data, where does the max occur? At 9 seconds. So I don't have to move, I don't have to slide anything. These are the same. So there is no phase shift. So I end up with this. Now, the frustrating part on this problem is when you type it in like that, it doesn't accept it. You have to put the pi and the x in the numerator. Yeah, I know. And so I doubt I'll ask you this question because these are exactly the same thing. That and that are identical. So the fact that it doesn't accept it is crazy. But they're both the same. Same answer. Anybody need help with theirs? Okay, guys, that's it. So tomorrow, bring your notes with you. It won't be long, guys, because these problems are kind of involved. It'll probably just have like maybe 5 questions at the most. Okay, good. That'll work.